Last time we did talk about domain and range a little bit, so we're going to talk about a little more about domain and range, and this time we're going to look at domain and range, getting the domain and range off of graphs, and see what that entails. All right, so let's remind ourselves here what we mean by domain and what we mean by range. Typically, when we're talking the domain and range, the domain is, well, officially it's the input values, but usually when we're talking about an equation, what values are we talking about for the domain? It's the x values, right? Yeah, so the domain are the input values, i.e. the x values. And typically the way we state it, it's the x values. And then that means the range then is the output values, or typically our y values. Now when we're talking about functions, the y values are f of x, yeah. So that, either or, okay. All right, so with that in mind, let's look at the domain and range off of graphs here. Doesn't really matter, but let's say that's 3. So I want to know, for this function here, right, it passes the vertical line test. So this is a function. What's the domain and range of this function? Well, our domain are the x values. And so we look at here, since I don't have a table, I guess I could make a table, but I don't have a table, or I don't have a function to go off of, let's just see if we can figure out what is our domain. Well, looking at the graph here, yeah, this is kind of the starting point for this graph. -2, 0 is the starting point. And so there's nothing on this side of -2. And so that's telling me right there, there's no x values less than -3, right? Because I'm looking at the x-axis, the horizontal axis here. There aren't any values beyond -2 to the left of -2, right? Do you agree there? All right, so it starts at -2, and then what about the x values over here? We've got x values over here, don't we? How do I know? Well, if just pick one, pick 4. There's a point associated with x is 4, so that's got to be a part of the domain. There's a point associated with x equals 4, so that's part of the domain. The 4 is. What about 5? Yes, and usually, you know, if your graph goes off of the axis there, it just continues going. So what is that telling you? It's going out to infinity, yeah. So I've got -2 out to infinity. There's a couple ways we can write that. We could say it's the x values greater than -2 and equal to -2, since I've got the point there at -2. So anything x is anything greater than or equal to -2. Now I also could write that in interval notation, which is probably the way the book will write the answers, or they will have the answers. And that's where, yeah, we use the infinity there. We start at -2, but then it goes to the right infinitely, right? So that would be the infinity. And then we'd use a bracket on the -2 in the parentheses. Now, tell me why I use the bracket there. Yeah, it could be equal to -2. If I put a parentheses there, that would mean -2 is not included. Bracket means -2 is included. So yeah, -2 is included. If -2 wasn't included, you'd see a little circle there, open circle. So -2 is included, so that's why I use a bracket, and infinity always has parentheses.
So
good on that?
So the bracket's basically saying it stops at -2. This is where it starts at, it's right here.
It starts right at -2. Yeah, you include -2. Yes. All right. Now the range, that's the other side, right? That's the y values. And so we're thinking about the y values here, the y-axis. And so what do you see not being in the range, the y values?
Below negatives.
Anything below the x-axis right here, right? The negatives, yeah. There's nothing y value concerned below the x-axis, so that means there's no -1 for y, no -2, negative. There's nothing in the negative range for y. Where does y start?
Right at 0.
It starts at 0, doesn't it? Because you've got this point right here, so you got to come across here. The y values start at 0, don't they? Because this point is -2, 0, so there is a 0 y value. And then everything above 0. So the y values I've got is anything above 0. So y, and including 0. Anything greater than or equal to 0, so that would be an interval notation 0 to infinity. Because it starts at 0 and then goes up. The y values here going up, that would be the infinity side of the line. Okay?
Why would it be 3, where that curve is? Yeah.
3 is included, but there's y values below 3. Think about a table here. X and y values. Don't I have, wouldn't this point be -2, 0? So I've got a y value of 0 here. So you got to look to the side, not just where it crosses the y. You got to look to both sides of the y-axis. There's nothing on either side of this, the y-axis, so these aren't part of the range here. But you got a y value over here, you got a y value over here, you got a y value 2 right here. You see, so there's points associated with those, just like we did with the axis. So it's not necessarily where you cross the y-axis, it's what's on either side of the y-axis.
Okay.
Because there's no specified ending.
All right, so here's number 2. And it's half a circle. There's 2 up here too. 2 to -2, and then up to 2 there. All right, so again, domain and range. Domain and range. Yeah, so these, since they don't go off the axis there, that's where those start and stop. So what does that mean as far as domain? What are my domain values? This one, this interval notation is a lot easier on this one. I can show you the inequalities on it, but what's the domain here? What are the x values?
-2 to 2.
Yeah, -2 to 2. I've got points from -2 to 2 associated with these x values. I've got an x value of -1, I've got an x value of +1, a half, 1.5. I've got all those x values from -2 to 2 involved. So that would be our domain. And as far as inequalities there, if you want to do that, x is between -2 and 2. So you could write it this way, with the compound inequality. -2 is less than or equal to x is less than or equal to 2. But like I said, I would prefer -2 to 2. Is that okay?
Mm-hmm.
All right, what about the range, the y values?
0 to 2.
0 to 2, yeah. So I've got y values, they start at 0. There's, again, nothing below the x-axis, so there's no negative y values. Talk about the y-axis here. There's no negative y values because there's no graph on either side of those y values. But, yeah, on these side, the top side here of the x-axis, I've got y values here, here, and all the way up to 2. Now, there's nothing after 2. There's nothing y value up here, right? 0 to 2 would be the y values. Okay? Good? Question? One more. All right, so this one, you've got a high point here, is that 1, 4. Crosses the y-axis at -1, positive curve shape here. Yeah, so this is probably, well, that one's one we'll probably talk about more. This one maybe later, but this is more like one we would come across as far as graphing is concerned. So let's talk about the domain and range right there. Domain and range. Domain for the x values.
Infinity.
Any x value, couldn't it be? Yeah, because this graph goes off the screen, so to speak. This graph's going to continue, it's angled out, isn't it? So the graph's going to continue angling out. So yeah, not only does it have, it looks like -2 is kind of where it goes off, but there is a -3 value because if you continue that graph on down, there is a -3 point for x. Same thing over here, there's a +4, this is where it goes off, but if we go to 5, if we continue that graph out, there's going to be a point that goes with that +5, or 6, or 7, infinity. And then back this way too, right? Negative infinity, we haven't done one that goes this way, so that would be negative infinity to positive infinity as far as the domain goes. Could be any, another way to say that, x could be any real number. X could be any number. There's no disqualified x value there, like we had here. Is that okay?
Why would there be parentheses instead of brackets there?
Infinity always has parentheses. You never, because you're never, remember brackets mean you include the endpoint, so you're never,
Because there's no specified
you're never going to get to the end of negative infinity or positive infinity. It just keeps going. So that's why they use parentheses. Parentheses always on infinities. Same thing for the range or different?
+4 to -infinity.
Okay, so yeah, there's nothing above +4 here for the y values. So it kind of stops at +4.
Is that gonna be a bracket then?
It's going to be a bracket on the +4. Now, and that's why I mentioned this one specifically, because which way does it go? Well, if you think about it, the negative infinity, that's on the left, or the less than side. So the +4 is the greatest value, isn't it? Everything else is left. So the negative infinity goes this side.
Oh,
Yeah, it's a little tricky there. That's why I mentioned this one specifically. The order here, the negative infinity, yeah, the y value is going to keep going to negative infinity, but those are the smaller y values, if you will. So they go on the left here in this interval notation. And then the 4 is the right endpoint. And again, it's a bracket because you're including 4. So that was a little tricky, but is that okay? Does that make, it's 4 is the top value, and then it goes down from there, but that's how you need to write that. Okay? Any other questions on that? All right. One other piece here that I want to talk to you about are the zeros of a function. By zeros of a function, what I mean by that, it's not x value 0. The zeros of a function are what makes the function value 0. So it's the zeros of a function, that's going to be the input values, or the x values, for which the input value is 0. Output value, sorry. The input values for which the output values, the y values, function values, is 0. So to make a zero a function, the function value is 0. For example, f of x equals 2x plus 8. Let's make it plus 9. F of x equals 2x plus 9. the zero of this function is x is negative 4.5. Why is that? What do you get if you plug in x is negative 4.5? 2 times negative 4.5 is negative 9 plus 9. You get 0. Yeah. All right, so that's what makes negative 4.5 a 0 of this function, because it makes the function value 0. All right, so that's what a 0 is. It's the value that makes the output value 0. Now, in practice, how do we find those? Well, we use what a 0 is to our advantage, because the way we could have found this, I gave this one to us here, but the way we could find this, could we say 2x plus 9, set that equal to 0? And guess what? If you solve that, you get negative 4.5, don't you? Okay, so that's how you find zeros, is you make the function value, change f of x to 0. So that's our strategy. To find the zeros of a function, you set f of x equals 0, and you're going to solve for x. And that'll give you your zeros. All right, so find the zeros here. F of x equals 3x squared plus x minus 10. So yeah, this one is actually the solving type of equation, because to find the zeros, zeros mean f of x is 0. So I'm going to set f of x equal to 0 and solve whatever equation that turns out to be. How do I solve that one?
Can you factor it?
Factor, maybe. Could be quadratic formula, maybe. Yeah, so that's, we went over several types of solving types of equations, and that's why, because you never know what type of equation you'll run into. So yeah, you try factoring, or go the quadratic formula. So it'll be 3x and x for 3x squared. We got minus 10, 5 and 2, 10 and 1, about the only ones, right? Let's try 5 and 2, maybe 5 here and 2 here. And a minus and a plus. How do I know that's right? Well, 3x times 2 is 6x, and then minus 5 and x is minus 5x. What do those add to be? 1x, yeah. That's how I know that's right. All right. But then, once we get it factored, yeah, then you set each factor equal to 0. So this one's going to have 2 zeros, isn't it? Add the 5, and divide by the 3. 5/3. And subtract 2, negative 2. So my zeros here, got 2 of them. 5/3 is 1, and negative 2 is the other. Yes? Good? All right. All right. Find zeros. Deal. G of t equals square root of 5t plus 7. G of t equals the square root of 5t plus 7. Well, all right, so this one is an f of x, but what are we going to do? Same thing?
Yes.
I think so, yeah. Yeah, we're going to set the function value. It may not be f of x. In this case, the function value is what?
G of t.
G of t. So I'm going to set g of t equal to 0. So the zeros are just the function value is 0. So the function value is g of t. So I'm going to set g of t equal to 0. And solve accordingly. Yeah, so we talked about square root equations. Square both sides. Where 0 squared is 0. But that'll get rid of the square root and the square. So this side will just be 5t plus 7. And then subtract 7 divided by 5. Maybe 7/5. All right. That's my 0 here. So it's just, I mean, it's not hard. It's just knowing. You got to know if I'm finding zeros, I'm finding f of x or g of t, whatever it is. The function value is 0.